Hi parents, I wanted to make a little video for you because we are starting our first multiplication unit with whole numbers. And I know sometimes we do this a little bit differently than the way we did it when we were younger. So I wanted to go over and show you the different ways that we do this so that you can better support your students at home. So I'm going to show you the 3 ways to multiply 2-digit numbers by both 2 and 3-digit numbers. There's 3 different ways that we're going to use. We're going to use the area model or box method. They often call it the box method. We're going to use expanded algorithm, also known as partial products. And then I'm going to show you how I connect both of these to the standard algorithm that you're used to. This way you can kind of support your students. I know that some of these ways are going to seem like they take a lot longer, but they are showing the students the process behind what we're doing as opposed to just memorizing um, the way to do the standard algorithm. And they will see problems like this both on their topic tests and on the EOG. So it's very important for them to understand these parts. So let's start with a 2-digit number. So we're going to start, or 2-digit by 2-digit. So we're going to start with 12 times 15. And most of the time, the students are going to see these in word problems. So it'll be something like this word problem right here that would then have that as their number sentence or expression. So with the area model, we're going to start by drawing a box, hence why it says box method. And then we're going to be splitting our numbers up. So we're going to split our box very similarly. So we know 10 is going to be bigger than 2. So we're going to make that space bigger. And this is going to be 10, and this is going to be 2. And then the same thing, we know 10 is bigger than 5, so we're going to split that as bigger. So this will be 10, and this will be 5. So this kind of spatially shows them how their number should be. So this should be the biggest number. This should be the next biggest number. This will be the next biggest number, and this will be the smallest number. So in each box, you're going to multiply the numbers that meet in that box. So this big box would be 10 times 10. So 10 times 10 is 100. This box would be 5 times 10, which would be 50. This box would be 10 times 2, which would be 20. And this box would be 5 times 2, which would be 10. And then we add it all together over on the side. So we're going to have 100 plus 50 plus 20 plus 10, which will give us 180. And so that is our answer. Now with expanded algorithm, we're getting a step closer to the standard algorithm, but we're still breaking it apart like we did here in the box method. So we're going to write it out just like we would write out our standard algorithm. But when we multiply, we're going to write out each of the answers down on the bottom. So first we're going to do 5 times 2, which is the same thing we did here, which is 10. So that's 5 times 2. Then we're going to do 5 times 10, which is the same thing we did here, which is 50. So that's going to be 5 times 10. Then we're going to do 10 times 2, which is the same thing we did right here, which is 20. And then we're going to do 10 times 10, which is the same thing we did here, which is 100. And then we're going to add it all together, and we get 180 again. So it shows them this same box method, but moving closer to the standard algorithm. Then the next step is the standard algorithm, the normal thing that we are used to seeing. So 12 times 15. So each step, I'm going to connect it back to what we did over here. So I'm going to do 5 times 2. Well, over here, we saw that was 10. But instead of writing it like this, we're going to have a 0 in the ones place, and we're going to carry our 1. Now, there is one other thing I usually tell them to do. I tell them to start by circling the ones place because this is where we're starting. We're starting with the ones place. Then I'm going to do 5 times 1, which is 5, plus 1 more is 6. Now we're done with the ones place, so we're going to mark that out and we're going to bring that 0 down here because now we're working in the tens place, not in the ones place. And we're going to mark this off as well so we don't forget to not add that. We don't want to add it this time. So we're going to do 2 times 1, which is the same, actually, sorry, 2 times 1, which is the same thing as over here, was 10 times 2. And if we put that 2 here, we can see that 20 that we got right here. And then 1 times 1, which was over here, was our 10 times 10, is 1. But if you look at it, that's 100. And then we're going to add it together. 0, 8, and 1. So they can see the connections between what we did here and that we're carrying, and then down at the bottom, they can see why they had to put that 0 in. So once they learn these processes, we move into the standard algorithm. Now let's try it with a 3-digit by 2-digit. So this time we're going to do 163 times 14. All right, so let's start with that area model again. So we're going to draw out that area model. Okay, so 100 I know is going to be my largest. So that's going to be my 100. And then there's going to be my 30. And then my 3. So this is going to be 100, sorry, 60, not 30, and 3. And then I've got my 10 and my 14. I mean, my 10 and my 4. So my 10 and my 4. And we're going to do the same thing we did up here. So 10 times 100. And we've talked about how you just have to multiply the first number and then add the zeros. So that would be 1,000. And then 10 times 60. So again, I'm going to multiply the whole numbers, which is 6, and then add my 2 zeros. And then 10 times 3. So I'm going to multiply my whole numbers and then add my 0. Then down here, I'm going to have 4 times 100. So multiply my whole numbers and add my zeros. 4 times 60, multiply my whole numbers and add my 0. And 3 times 4. And then I'm going to add it all together. 1,000 plus 600 plus 30 plus 400 plus 12. And we also talk about how important it is to line these up. I often will remind the students that they can use graph paper to do this, that it helps them line it up much better. And they will always have graph paper, including on the EOG. So 0 plus 0 plus 0 plus 0 plus 2. And 3 plus 1 is 4. And 6 plus 4 is 10. So this should be our answer. Now let's move to the expanded algorithm. So we're going to have 163 times 14. Okay, so we're going to do 4 times 3 is 12. 4 times 60, we have that over here, is 240. 4 times 100 is 400. Oh, I forgot my 240 when I added over here. That's not good. That's going to give me the wrong answer. And this is why we have to be careful. I always tell the kids we have to add that back in. And I noticed that because I went back and was looking at it when I was doing this one. 10 times 3 is 30. 10 times 6 is 600. 10 times 10, I'm sorry, 10 times 100 is 1,000. So then we'll have 2 and 4 plus 1 is 5, plus 3 more is 8, and 2 plus 4 is 6, plus 6 more is 12, and we got the same answer. And again, we can see these broken down products over here in this one. So now we move into our standard algorithm. So 163 times 14. Again, I'm going to remind them we're working in the ones place first, so we're going to circle that. 4 times 3 is 12, just like we had here. But this time we're going to put the 2 down here, and we're going to carry the 1 into the tens place. 4 times 6 is 24, plus 1 more is 25. So 5 down here, and carry the 2 new tens into my hundreds place. 4 times 1 is 4, plus 2 more is 6. Then we're done with that. So we're going to bring that 0 down, and we're going to make sure to mark these out so that we know that that's taken care of. Then we have 10 times 3, which we had over here, was 30. 0. Carry our 3. 10 times 6. Oh, try that again, Miss Tinker. I'm so sorry. That's not correct. Our 3 is going to go down here because we're really doing 1 times 3, but we want to think of it as 10 times 3, which is 30. 1 times 6 is 60. Really, 10 times 60 is 600, and we can see it's 600. And 1 times 1 is 1, but it's really 10 times 100, which would be 1,000. So then we have 2, 8, 12, and 2, and we get the same answers there. But again, once they understand these place value parts of it, it makes this a little bit easier for them to understand. The big thing that they that they often forget to do is to bring that 0 down in the tens place, and then they forget to mark off where they carried. And so they'll add that carry back in again, and we don't want them to do that. So hopefully that shows you, I mean, you know how to do the standard algorithm, but hopefully that shows you the 2 other methods we're using, expanded algorithm and partial products. And again, they're going to see these on their tests. And a lot of the tests, when they have the test, they will either leave one of these spaces blank and ask them what goes in there, or they'll leave one of these blank and ask them to figure out what this answers or what this what that product was. So if they know it's 10 times something equals 100, they have to figure out that that's 10. So they really have to understand how this works together, because they will see that show up in their quizzes, on their tests, and on the EOG. So I hope that this has helped you to understand how to support them when they're doing the area model and expanded algorithm. You won't see a whole lot of homework like this. We aren't going to send a whole lot of homework. But if they aren't doing well, they're having trouble understanding it, this is a resource for you to use at home. The other resource that you can use is going on Canvas, and attached to each day on our calendar, there will be a video of me teaching the lesson, and you can go back and review that with the students. I will be showing the students how to get to their calendar, but for you, if they go onto Canvas, there's a little button on the left side that says calendar, and they just click on that and it will be attached to there. So thank you again for all your support at home, and I hope that this helps.